All right. So welcome everyone. So this is a session that the team put together. Basically, the team has been working on PBTS, I would say since late last year. I mean, there's a lot of work that happened in the past few months. It's still ongoing with kind of like wrapping up, finishing up. But basically, the proposal-based timestamps, as you know, it's a different algorithm to calculate the block timestamps among the validators, something that some chains and some people will benefit from it. I actually am at Denver right now, and I've been talking to some people, and people are getting really excited about it on the prospects, depending on the use case. This is something quite interesting for them. I just met Dave from Osmosis. I was talking to him, saying this is coming, and he was really excited that this is happening right now. So why does PBST matter? So it's basically right now we have improved reliability for time-sensitive applications, applications that depend on a more accurate time, let's say, like Dexys, perps.
Uh, Andy, you might want to change your screen because we can just see the first
Oh, it didn't
slide.
change.
No, I know
Was
you put slideshow, but you might just want to like click through the second page.
okay. Yeah. You know, do you want to share? It might be better if you do. Okay, let me see. Uh,
I think you can just exit the slideshow. I assume you're in slideshow
yeah,
view. You can just be
yeah,
in the normal view.
yeah. And the reason I'm just asking maybe Lawrence because I'm in the hotel right now and I don't know if the internet is that good. So
Yeah, I can do
probably
backup. Give me one
better.
second to pull this out. How are we doing now?
Yeah, it's coming. Yeah, I
Great.
can
Okay.
see. Um, everyone can see it. That's good now. Okay,
Yeah, I think we're good.
okay. So yeah, so there are many benefits from having PBTS. People on this call have a good use case. So there's also the fact that like for like clients that rely on like the time and block time for verification, this is improves the reliability of the block verification. Um, and also the potential for signature aggregation. That's an interesting use case that this might open up, like BLS signatures or MPC computations, things like this. And basically, it's just a simplified timestamp agreement. It's the way that the current way with BFT time, some calculations that you have to do. This is a simplified, better way to do, more efficient. Yeah, I have to maybe go next. Yeah, so basically, currently, the way Comet calculates the timestamps is what we call the BFT time. So basically, it's weighted mean average of the timestamps received from the validators. So and also weighted by voting power, right? I don't know if anybody on the team wants to talk about BFT time, but basically it's the current implementation.
Sure. I mean, we can just briefly go over it just so people have context of what is currently enabled, right? It's not BFT time is not like inferior in terms of if you existing chains stay on it, right? But there is extra computation that is involved in calculating a like timely timestamp that's going to be somewhat less reliable or less true to like a real timestamp, your system clock. And so by moving to PBTS, you're also not only are you ending up with potentially more reliable timestamps, but you're also eliminating the extra computation involved in calculating those timestamps across the network.
And yeah, and it also eliminates the fact that you need to track the timestamp for each validator, like removes that. So that's the use case for the signature aggregations, right? Like, so we don't have this timestamp anymore.
Yeah, I don't know if anyone has anything to add on BLS signature aggregation and PBTS enabling that, or we can talk about that at the end as well and continue.
Again, but this is very simple and short. So the vote message in Comet, they have a timestamp. All the fields of a vote message are the same, except for the timestamp that, of course, is different. So you cannot aggregate the vote message because they have a field which is different. And to aggregate something, you have, so to aggregate votes, you need the votes to be identical and be signed by different keys, right? So they aggregate, so you keep the same payload and aggregate the several signatures. The fact that the timestamps are non-deterministic, so they are just numbers, everyone put a different number. This prevents us from aggregating votes properly. That's the goal of BLS.
Mm-hmm. Yeah, I think this is a good segue to the next one.
I would like to add something to what Anil said. So just to make it clear, so at this phase of PBTS, we are not removing the timestamps from the votes because we cannot, because that would be breaking the block format. And as you know, we are not able yet. We are yet not able to modify the block format without forcing an upgrading chain to hard fork. And this is something that well-established chains like, I don't know, Osmosis, the Hub, but also many others, Secret, I'd say, all these long-standing chains. I don't think we are at the point where we can actually require them to hard fork because our new version just contains a change in the block format. And this is something we will be working on shortly, but isn't there yet. So PBTS is going to be out. You guys can benefit from it, but the vote timestamps are still going to be there.
Yeah, that's right. Yeah, it's just a kind of like an enabler, but it's not, and so it open up the doors, but it's not like breaking. It's a good explanation for Sergio. And so PBTS, so the idea is that now the timestamp of a block is assigned by the proposer, right, according to the local clock. And then the validators will accept or reject that based on some synchrony related parameters. We'll talk more about there's more details about the concept in the next slides.
How that's calculated.
Yeah, so there's this concept of timestamp is acceptable, and Laura is going to go through and explain more about it.
For sure. So basically, the API that we're introducing is a message delay and precision value. So the way that we're going to be calculating whether or not a timestamp is, or the proposer's timestamp is timely, is within this window with negative precision, and then we are adding a message delay in addition to the precision value. And so at any point in the receive time window, a proposal will be judged as timely. And so we have also introduced the concept of adaptive synchrony parameters. And so with each subsequent round, we will be increasing the message delay by 10%. So you can see based on just like some recommended guidelines, potentially what that looks like for each subsequent round of consensus. And
yeah, maybe on this. Does anybody from the team wants to talk about the delay? Why is it important, or I don't know, someone from PBTS?
The 10% value,
the-
you mean?
Yeah.
Yeah.
Why is that, right?
I can jump in again. So the problem of the message delay, if you can go back to the previous slides, is that it defines the essentially the lower bound of a timestamp. So a timestamp cannot be too old, too far in the past, otherwise we reject it. The problem is that if you put the message delay can go to the next slide, to a very small value that doesn't represent the actual delay of the network, this means that most of the proposals that we are going to receive will have a timestamp too much in the past because we choose a message delay which is small. This is very problematic because all the proposals will be rejected because the timestamps are bad. And this can halt the network, essentially. And the other problem, of course, is that in order to change the message delay, it is a synchronous parameter. You need a run of consensus. So if you cannot get consensus, how you change this parameter? So the solution here is essentially, as we fail to commit a block at round 0, we start slowly increasing by 10% each round the message delay, so that eventually the adopted message delay will be representative. So the message will be received with a message delay which is lower than the configured one. So these we discussed a lot of solutions to avoid this halting problem, and this at the end was the one we have choose.
Andy, you had something to say.
Yeah, I have a question. So basically, you keep increasing until you can adapt, right, to the, and does it, so the next round it goes back to the default value, right?
Yeah, that's a very good question. This is like the timeouts in Comet. So the timeouts we set for round 0, and each time you move to a new round, we increase the timeouts by a little, by a delta. When you when you start a new height, you go back to round 0, so to the original value. So this happens every height. So it's not, it's not.
Yeah, that's good. Okay.
I have a question of why this one is exponential and the original synchrony parameters are linear.
That's a good question.
This is a good question. Actually, we didn't. So in the case of timeouts, you have 2 parameters: timeout proposed and timeout proposed delta. And we increase linear by delta. Here we could have used the same approach, so linear increasing, but how do we choose the amount of increasing by round? We could either add a new parameter, but this is super complex for a corner case, or we can, actually this is an exponential, but it's a super slow exponential, right? So it's 10% per round. You take around, I think, 8 rounds to double here, the value, 7, 8 rounds, so.
Yeah, I'm not saying they seem like they're trying to solve the same problem, so I'm not sure which is better. It seems like you have better guarantees with the exponential version, but yeah, it seems to me like they should roughly have the same logic, I guess. I don't know whether that means which one needs to update, but yeah.
Yeah, so answering that, so yeah, this is something could be changed. I mean, that our design is not really bound to the fact that this is exponential rather than linear, right? So we could change that. It's not a problem. As Daniel explained, the reason we are putting it as exponential is because the exponential is kind of more flexible in the sense that if you say like we didn't want to put the 1.1 as a parameter because as Daniel said, it would be like more it would be more complex for a problem here that is extreme. So this will only happen. This would only be a problem if a chain sets some silly values for message delay. If the chain sets a silly value for message delay, this chain holds, and you cannot even pass a government proposal to change it. And so it's kind of like this chicken and egg problem. So we wanted, but that we know that this is very extreme. So like I would say that like reasonable chains will never fall into this. So we didn't want to add more complexity to to the parameters we are exposing. And we believed, but it's probably a feeling, is there's no like scientific, we haven't had like the time or the energy to go explore, the pros and cons about arithmetic versus geometric. And so we could change it. If you folks believe that, have strong reasons to believe that it should be arithmetic, we can change it. There's no problem. It's just that with arithmetic, if you hard code the 1.1 or whatever parameter you're going to have there, is basically it's basically a straight line. Whereas here you have an exponential, which means that, like the value, the actual value of the 1.1 is less relevant than the delta for the timeouts. I know it's not a very well, it's not like a well thought out explanation, and I insist we are open to changing it if folks think that it should be arithmetic.
No concerns. I'd have to think about it for a bit. I have a question on the precision and message delay parameters. Are those in state, or are those sort of off chain in config files, for example?
Those are consensus parameters that are set by that, like, you have your defaults that we set at the config level, but updating them will require and like effectively an upgrade.
Got it. And then
we believe,
sorry,
we still had doubts. So I know this is a bit off topic, but we are aware that for many years, we've had the commit or 10-minute timeouts in config files. I still have mixed feelings about that decision, to be honest. In 036, which was retracted, all those parameters had been moved over to be consensus parameters. There was some resistance in the community, so it was not really consensus. That's why we did not forward port that change into 37 when we abandoned 036. So to me, like, the controversy is the rather than here, it should be put on the Tendermint algorithm parameters. Why are they config values? For instance, the very obvious one is the timeout. This is something we need to do very soon, which is consensus timeout is something that if not set synchronously everywhere, you start getting plenty of round ones all over the place. So performance really would be terrible. And so you can only avoid that by convention, by basically keeping kind of control over all the validators to say, no, please set this value, otherwise you're screwing up the network. That is not, I don't think that is acceptable. So probably the one that is least questionable is consensus timeout. We should move it over. And the others we should discuss. Sorry, I'm getting off topic here, but basically this is like my answer to to your question on the PBTS side.
Yeah, it makes sense. I think we can solve it all at once, so I think it's fine for now.
Yeah, one question. Yeah, one question. So that you're talking about the timeouts, right? So based on can you go back
Oh,
just
sure.
one? I just had a question about. So you can actually, based on the timeout like that you have for the block, you can depend on the value that you set for the message delay, and the like the 10%, you kind of like can estimate how many rounds you can have, right? Is it like, because if you keep increasing until to the point, you're getting sure that, or you'll know based on some calculations that you'll have this many rounds, right? To that needs to in that timeout for the block. Does it make sense? Or I'm just saying, I think there's some dependencies on the message delay. I mean, to set a good value will depend on the timeouts that you have for the block, right? Which we're kind of like you're saying. I don't know if it makes sense what the question, but I'm just thinking that this there might be a way to come up with a good value for the message delay based on the timeouts that you have.
Yeah, it makes sense. Both of them you have to base your values from some measurements on your network, right? Some estimates on how long you take to do some processing, and then you can use that information to configure both.
Okay.
Actually, I mean, I hadn't ever thought about it that way, but it's true that message delay value could be whenever we move over the timeout values from config toml to here, we might reuse this value actually, because it's
Yeah, you could initially,
yeah,
if it's a consensus parameter, you could just say, or like the number of rounds is kind of like dependent on the message delayed, right? And the precision, of course, but so you can go back and say, well, this is a good message delay based on the timeout for the block, right? But you can just calculate eventually and set a good number for now. But eventually this could even be automated in some way. All right, we can move on to the next if you want.
Cool. Yeah, so I mean, similar to vote extensions, we'll have like a PBTS enable height. And this is like a one-way change, right? Like upgrading to PBTS is irreversible, and you'll need a coordinated upgrade. So yeah, that will be a parameter as well as our synchrony params, so message delay and precision. And yeah, so these are again like suggested defaults, but I imagine those will be tuned on a per network basis. I don't know if anyone has any questions or anything to add on this.
What part is makes it irreversible? I guess would be my question.
Oh, you mean in terms of like calculating like your upgrade to
like suppose I have like an upgraded height H and PBTS gets enabled, but I don't know, there's like something that goes wrong. Like why can't I revert like to using BFT time? What I'm trying to, because we have like a somewhat bespoke upgrade process, so I'm trying to see if it's actually reversible for us, but I don't really yet understand the last point of upgrading to PBTS is irreversible. Like from the point of view of Comet, like what really makes it a one-way ticket?
Yeah, Sergio, you might be able to expand on this.
Yeah, so I'm just thinking how best to reply. I mean, I have several ways to reply this, but I don't want to be to sound convoluted. So, okay, so the simplest explanation is we chose not to support it. You know, like when you are building this from a software engineering perspective, it's like you decide what your requirements are, and we decided, or we came to the conclusion that reversing it was not a requirement. In the sense that this is kind of like when we go from from BFT to PBTS, conceptually, we are basically upgrading to a version that has it, and we want to eventually, for all change, to have PBTS. The reason why we're doing it with this flag, with this consensus param,
I think Sergio's frozen. I can give you much more, I don't know, pragmatic answer to that. The blocks in BFT time, so the current method. Sergio?
Yes?
Yeah, we lost
you. You froze a little bit.
Yeah.
Oh, I'm sorry. Yeah, my network has been acting up all week. So, okay, let me try to summarize. So, the initial intention of this was to make the feature would well have been defined or designed or specified and implemented without this parameter, and just saying, okay, when you do a coordinated upgrade, everybody by that, at that height, everybody starts doing PBTS, and that would work. We decided to make it more flexible for applications to say, no, you don't need to switch to PBTS at that point. We allow you to do it later, so that you first upgrade, you let it soak for a bit, and then basically you activate PBTS. We don't see any reason why you would be like, okay, we don't see we consider the reasons for or use cases for going back to BFT were not compelling enough to support this. And then the second part of the answer is, if that was the case, if we had to go back to not to BFT, that means that this parameter, as you can see, would not be enough because it doesn't contain enough information. Remember, this is done in such a way that when you look at the history of the chain, for instance, when you're doing blockchain on old blocks, you are supposed to be using the algorithm that was active at that height, right, all the time. And by that, what you have to do is you have to be reading the consensus params. So if you wanted to make it to deactivate it, so activate it, and then once activated, deactivate it, that means that this integer should be a list or or a set or something like this, which would make the whole design more complex just to support that use case. So that's kind of the reason why.
Yeah, Daniel, I think wanted to add something.
And one more thing, just one more thing. So there is though a way where you can actually change your mind. Okay, there is a condition when you could change your mind. You might so you might say I am upgrading at height 1000. Then the chain, so there is a governance and say, okay, so by height 2000 we will be activating PBTS. So you still can change your mind by removing, deactivating it, as long as you didn't reach that height. That is possible. Also with VOR extensions, by the way. So let me repeat the use case. Like, you reach 1000, you upgrade. You at 1100, you propose 2000. But then at 1700, people freak out, say, wait, we're not sure we're ready. You can still pass another government proposal to go from 2000 back to 0. So as long as you didn't reach the actual height, you still can change your mind. But once you reach that height, you have to stay with PBTS.
Yeah, just to conclude yes, it's just required. The validation of a block depends whether we are running PBTS or not. So if you shift from BFT time to PBTS and then shift back, how we are validating the block. So while we at BFT time are validating the blocks of PBTS, we have the solution for the opposite. So if you are in BFT time and move to PBTS, you can validate the blocks on there. If you allow to change, go and forward, back and forth, you will need to keep all these ranges. So it becomes super complex, right? So we are backwards compatible, but not forwards compatible. Let's put it like that.
Okay, so I think it would be like reversible, but only via hard fork of the application, compacting the state, but because it's part of the validation rules and the BFT time PBTS one is not supported, you have to have that step, like a non-resetting like upgrade. No, sorry, like a non-zero height, upgrade. Okay, yeah, that makes sense. Thank you.
You don't necessarily. Maybe this is I'm thinking real time, so please take it without getting off track.
Yeah, for sure.
You wouldn't need. I don't think you would necessarily need a hard fork. You would need, us to implement an extension of the feature. So what you're actually suggesting is being able to be reset. That means that we would need to come up with like a way in a new version to extend this parameter to us, I don't know, a list of intervals or something like this, so that then you can do it. You see, it's like you're not doomed, but in principle, you would need like a more complex feature than the one we have implemented here.
Yeah, I think doing a hard fork is fine, and like not supporting like the two directions is sound. Like like doing a hard fork isn't great, but also like this seems like it shouldn't be like the handling that scenario like shouldn't be resourced too. I mean, it's like your your resources, but I think it makes sense, like the choice of supporting BFT time to PBTS, but not the reverse. I just wanted to have the map in my head. So
yeah, and I would like to add that what Lazaro wrote in the chat is a better, is a better way of wording the beginning of my answer. So that's basically what I wanted to say, but I think he managed better than I did in the chat.
Okay, cool. Thank you.
Cool. Okay, so
sorry, Lauren. Something I wanted to say, because this is being recorded. So these defaults that you see here, they are preliminary. We have by the end, if I'm not wrong, by the end of this presentation, we're reporting on our current efforts to find them out. So these are preliminary, yeah.
Yep.
These defaults, just for the sake of the recording.
Yeah, so literally going into the next slide. So these are, I have two more slides, this and the next slide, from some preliminary QA results in terms of the expected message of a network. I believe this is including latency as well in some of the tests, but is Hernan on the call?
Oh,
No, okay.
Yeah, he's here.
Cannot hear you, Hernan.
Hernan, are you
Not on mute,
around?
cannot hear you.
Yeah, I'm here.
Okay, we can hear.
Yeah, do you want to talk a little bit about some of the tests that you ran, preliminary tests that you ran for QA for the PBTS feature branch?
Oh yeah, I can. So yeah, the setup for this test was 200 nodes, the usual setup we use for the QA process. So in particular here we had used latency emulation. It means that we introduce some delays. We randomly distribute the nodes in let's say data centers, and introduce some delays between the nodes. Yeah, we just run the nodes with a constant load of transactions, what we call the saturation point of the network, which is about 400 transactions per second. I think this is the case here. So yeah, we collected some metrics on that. I don't know, maybe who wants to talk about in particular about these metrics?
This also might be useful.
yeah, I think the previous one is better to explain. I can.
Sure.
Yeah, so here are, like is written there, is the time you receive a proposal subtracted by the proposal timestamp. The proposal timestamp should be the time at which the proposal is produced and sent to us. So essentially, okay, the visualization here is not great, but you have 0 and you have positive values and negative values. Negative values here mean that the proposal timestamp is in the future, because when you subtract your time for the proposal time, it becomes negative. It means actually subtract, yeah. Anyway, the values below 0 are proposals with timestamps in the future. We don't expect to see that because, of course, if the clocks are perfectly synchronized, the reception time is bigger than the sending time. This is real time, how it works. But it's fun that this is an experiment in DigitalOcean, and we can observe that there is some clock skew, because you have some values on the negative side. On the other hand, we can see that most of the clock skew that we observe is up to the half of a second. Is the first bucket bigger bucket than on the left? Let's put like that. So that bucket are values from essentially from 0 to half of a second in the future, so negative. So from that perspective, and these are preliminary results, we can say that the clock precision of a half of a second, which is the current default value, is a good one. Andy, then I move to the next.
Yeah, so one thing I think we haven't mentioned, or maybe made not clear with the PBTS, is now that the validators are voting, we're accepting the timestamp. So there's a threshold of 2/3, right? Maybe you can talk about that, Daniel. So even though you might get some negative values, I think in the end that will not skew, because you're not calculating an average or something, and it's not weighted by voting power, right?
Yes, I think that if you take the first bucket, the leftmost bucket, the small one, from -10 to -half, -0.5, these are proposals that are going to be rejected because they are more than precision negative. So the difference is less than half of our precision. You see that the amount here is very small, and like Andy mentioned, this should not really impact the progress of a network. We would like to tolerate 1/3 of the nodes that have not perfect clocks. But also another point, we run these experiments without really synchronize the clock. So this also reveals the importance of using NTP or some service in order to synchronize the clocks. I think Sergio wants to say something.
Not really. I mean,
Okay.
I agree with everything you said. That's all I wanted to say.
Go ahead,
Brenda
please.
has a question.
Yeah, so I feel like for this one, there should be a negative 0.1 bucket if you're suggesting a precision of 0.1, right? I would suspect a lot of this in the second bucket between negative 0.5 and negative 0.025 would fall into that bucket, but you can't tell from this graph, right? Yeah, I do have some concerns about the clock skew, and in particular, yeah, I guess the negative clock skew, right? Like in some cases, I guess as a proposer, you might be incentivized to like use a timestamp slightly in the past to prevent this issue from people rejecting your timestamp from being too far in the future. So I'm kind of wondering, you know, like we have we adjust the tolerance parameters by round to adjust for stuff like latency, but for clock skew, we're not adjusting for that right now. So it seems like pretty aggressive to use 0.1 currently. I think, yeah, like I think by default, everything in the cloud, like DigitalOcean, AWS, and stuff like that, does have clock synchronization, but a lot of the times those aren't like. So the clock should stay like in sync. Like if it drifts, then it'll like set it back to the correct time. I think that's pretty standard in most cloud services, but the accuracy of that like initial setting or every time it resets is actually not that accurate. I think it's probably like, you know, AWS, I think had it up to like 0.4, 0.5 seconds accuracy recently. And I think they're changing the standard to be more accurate, to be within like 0.1, but I kind of think that like 0.1 is a bit too aggressive in this case, and I'm wondering if there's other ways to prevent, like in the past, right? If you had someone at clock skew, it would just come out in the wash because of the medianization thing. But in the case that they literally can't, you know, get a block approved, then that's a little bit more of a disastrous situation. So I'll just stop there for now.
Guys, can I take this? Answer this. There's two things I wanted to say, Brendan. So the first one is you mentioned, so you guys have provisions for relaxing the message delay, but not the precision, right? So the answer to that is that in order to fix the precision, all you need to do is to properly set your clock, like start your NTP daemon or whatever. You don't need the chain to fix that. So if there is a chain halt because too many people are skewed, all you require the people to do is just basically to correct their clock, and then the network basically will spring back to life. Whereas for message delay is not that simple. For message delay is that if you should set a message delay which is too small, there's no way on earth you're gonna get a proposal accepted, and therefore the chain will halt. And the only way you have to change the message delay is basically via the chain by passing a govern proposal. So that is why we added something for the message delay and not for precision. And then the second one is I would like to state a little bit of the context of this. So this is something we obtained 20 minutes ago. So this is really hot out of the oven. And I just wanted to share with you folks, there are things we need to, like for instance, the bucket size that Brendan, you mentioned. Yeah, so we're actually planning, again, this is super recent. We just decided we're gonna run this again with much more granular buckets to get a better idea of the distribution. And then with that, it will allow us first to get accurate harder proof of what precision message delay should look like as default parameters, and also what should be what the bucket should be, because then you can see the whole distribution. So you can see, okay, so let's put the buckets this way. So this is something we haven't done. This is the first iteration. Second iteration is coming probably later today, but it's it's the point in time we had this meeting. And there was another thing I wanted to say. Oh yeah, and the negative thing. So the negative thing is that this is like, again, we discussed this for the first time half an hour ago, and we need to go there and see, what Daniel explained is our current hypothesis, our current explanation about that. But we need to go there and see what's going on with the clocks, with DigitalOcean, and also with our latency emulation. This is the first time we have been using Hernan and Daniel. Keep me honest here if I'm not saying the right thing, but my understanding is that this is the first time we are actually using latency emulation for something like meaningful. So maybe there is some quirk there that we are not aware of it, and that might explain why we're getting this negative stuff.
I have a quick follow-up question to that. So let's say if a validator has a really skewed wall time, right? In the past, that's not really a big issue because we just take the weighted medium, right? Going forward, if let's say my validator is off by like 5 minutes, then my block will always get rejected, right? There's no incentive on the consensus level that actually makes me want to adjust my wall time, want to fix it, right? Like, because I've seen in the past where like let's say I'm a validator, I'm just not proposing blocks, and it's fine because the next proposer will propose it, and then the network will experience a liveness issue, but I'll still get my rewards, right? So it seems like with this change, there's more ways that a validator can mess up and then just like creates liveness issue for the network. So I was wondering if there's any plan at all on a consensus level to have some punishment for proposer.
Yeah, I can tackle this. So first of all, replying, the standard value of precision and the recommended value of precision is half a second, at least. So 500 milliseconds. I think there was a typo on the, because in particular, there is a phenomenon called leap second. I don't know if you're aware, Bor, but in order to tolerate that, you need at least half a second of, this is a thing that happens every X years. But this is a good value or recommendation. So use at least half of a second, 500 millisecond as precision. So probably it was wrong on the slide. Regarding the last question, I think it's a very good one because we are talking about here the incentives, the logic, the incentives you have to use good or bad timestamp, right? And regarding punishing proposers, I think it's an idea that we already considered, but in particular for this case, it's very hard to distinguish between a proposer that on purpose is changing the timestamp of a block and a proposer, for example, that has very bad latency. So the proposer is in Tokyo and the rest of the network is in the US, right? So it's when you put synchrony in the middle, it's very hard to distinguish between bad behavior and slow behavior, right? So it's also hard to produce an evidence of that. So an evidence is something that needs to be self-contained and self-verifiable. And when you put time in the middle, it becomes very hard. Sergio.
Actually, it's very good. I would just like to rehash what you just said with a metaphor, okay? So to assume BFT time, so assume this doesn't exist, this PBTS doesn't exist, right? So how do you distinguish, right? A proposer that is just basically modified their code to just not propose, just keep proposal, because I don't know, in that chain, it takes a lot of computing resources. And so it's just basically not proposing, right? How do you distinguish in that chain? How do you punish that guy that is actually not proposing? It is impossible to show or to prove that the guy is not doing it, because it might be that their proposals are always coming late in the sense that other guys timed out, right? Timed out. The timeout proposed went off, and so somebody else went on and proposed, and then that proposal of round one is going to be taken. So, you know, since we are in a or partially synchronous system, there's always this thing about, and this is an impossibility. I mean, it's well known for decades, right? But it is hard to distinguish, or impossible. Sorry, it is impossible to distinguish somebody that is slow from somebody that is Byzantine. And slow meaning the guy itself or the network.
Isn't from the application level, isn't there any incentives for the block proposer, like in rewards and things to propose blocks? So if you get additional incentives, I mean, and if you're missing block, like to be a chance of being a proposer, then you might get an incentive to fix the clock, right? I don't know if that makes sense.
My take on that is just to quote what Brendan said on the chat, like probably, yes, that might make sense, but that's basically up to X slashing. So that's probably up to the SDK to come up with a way to enforce that at the SDK level. Remember, we are just producing evidence. We are not slashing anybody for anything. Yeah. It's actually the app that is taking care about the information we provide in terms of evidence or other behavior to slash. And as Daniel said, it is impossible to cryptographically prove that somebody didn't do anything in an asynchronous system.
So if you want to, we should wrap this in a while. Happy that if you take the right part of the graph here, we are talking about positive values. And the important point here, you have most of the message that have essentially, if the value is positive, and assuming here that the clocks are kind of synchronized, and we are assuming that the message delay is the positive part here. So you can say that most message delays in this experiment are between 100 millisecond and 500 millisecond, which is the bucket with more values here. We have some values of between half of a second and 1 second, less value between 1 and 1.5. And we also have a lot of values between 0 and 100 milliseconds. So based on this data, I think one can say that 2 seconds is a good value for this network, for this setup, for the message delay. And the point that this data, this metric is something we are offering, not only for PBTS, but also for chains that are running BFT time that upgrade. So it's good that you can have the same view of the distribution of the delays between the proposal timestamp and the time you receive the timestamp. And I think from this data, from this metric, we are going to improve the buckets. We realize that some buckets doesn't make sense. For example, the first one on the negative side. And this provides a good indication for which are the safe values, for example, for message delay. Regarding the question of adaptive message delays, assume here that you put the message delay to 100 milliseconds. We have a very big portion of the message that will never be delivered in less than 100 milliseconds. So you are going to reject all this message. And you have the problem. So the problem here, we are adapting a little by little, 10% by 10% until we realize, okay, this is a good latency. And again, we have the possibility afterwards, when updating the consensus value, to have observed the network and have some real data on each to base the choice of your consensus value. So here, based on this data, we'll say 2 or 2.5 seconds of message delay and half a second for precision are good values, are safe values for this network. If you have any questions or some other information you want, you are available here.
Yeah, I think just for the sake of time, we could just maybe move on to, I think Lauren had some couple more slides, and then we can always follow up on the questions on the channels.
This is really it in terms of just like QA results, and then where we are in terms of like the development phase. It's pretty much feature complete, with the exception of the adaptive synchrony params that's still in review. And then of course QA is ongoing. So really that's it. So we can continue. There's not much to add.
Folks, any questions, comments, inputs? So to me, like the biggest takeaway is, the two biggest key takeaways are the discussion that is going on in the chat, which is how do we make sure that validators are incentivized to synchronize their clocks, one. And the second was the dilemma between linear or geometric, or arithmetic or exponential. So for me, those are the two key takeaways. We might rediscuss that internally, and if you have further input on that, we would appreciate it.
And I think, as Sergio mentioned, the QA process is ongoing. This is very preliminary results, and I think like maybe by next week or end of this week, I think things will be progressing a lot more, so we might get more interesting results that we can also discuss and go over them in a later time.
Without making demands of y'all's time now, so feel free to address this async, but Brendan brought up something that I found was interesting about F+1 cabals and VFD time. the context around this is like, oh, if I have f+1 malicious stake, I can set the BFT timestamp arbitrarily far in the future, or like just mess with it. So I think the advice is, oh, applications should have like some sort of synchrony check that check that like the timestamp is within parameters. For us, it's one of the main reasons we kind of shied away from using time, like just switching to time-based mechanisms, and instead like use block time and things like that. However, like that's something like obviously like PBTS seems to unlock. So it would be really great to I think to have more analysis from experts on basically like, is this vector like patched? Like it seems that it should be, but having like more like sort of like, yeah, analysis that we can read and understand and proofread if necessary about like, oh, why this is like, why like now just having a little bit over of like the malicious stake threshold won't snowball into like being possible to corrupt the application state and the application's perception of time. Would be really, really great, I think.
I think I agree. Just some high level thought on f+1 Byzantine nodes is that, you know, over the months or over the years, I've realized that basically there are many things that go. I mean, you cannot consider normal a chain with f+1 Byzantine nodes. There are many bad things that can happen there. Many. I mean, I don't know if I would put any of my dollars in a chain if I think I have the feeling that this chain might have more than f+1 Byzantine validators. What do you think, Daniel?
Yeah, I think if you have much more pressing problems, you have more than 1/3 of Byzantine validators. But I was reading here, I think it's a good point to make. Probably is not clear from we didn't present like that, but BFT time, you can only tolerate 1/3 of the process being Byzantine. If you have more than 1/3, like you discussed in the chat, you can have the time corrupted. In PBTS, sorry, you need to have more than 2/3 of faulty process in order to corrupt time. Because a time is only accepted if 2/3 of process consider the block type, right? You have to consider that f of these or 1/3, okay, they accept anything, right? But you still have 1/3 that are correct process that have to accept the time, have to check the time. So in order to put arbitrary times that doesn't respect these boundaries, you need more than 2/3 of the network being Byzantine or having a very bad clocks. I mean, the synchronized clock. So you're increasing a lot the degree of fault tolerance of the algorithm by replacing BFT by PBTS. BFT time.
Yeah, that's my understanding as well. And just on the design, I guess, point is, I think it's a really good design goal to have that just like the threshold to cause really bad, really hard to detect failure is like as high as possible. And it feels like this is what PBTS like achieves, at least my eyes. And I agree, like it is baked in that like, oh, like we tolerate as much as like F amount of failures, but if there are like sort of like ways to increase this is like always really good. And the thing I found spooky about PBFT time is just like it without a synchrony check at least, but it feels like hard to detect and like a lot worse. We're kind of like safety maxis, and like liveness is important obviously, but because we have like a shielded pool and it's hard to just do upgrades about private state, preserving like those invariants at the application level are like just this is the mission critical thing for us.
Just as a data point, Daniel, maybe you can complement because it's, you know, my memory starts failing with age. But beginning of 2022, when this was first implemented in 36, I remember that William, so one of our colleagues at the time, he went out, I think, to Osmosis. I don't remember if it was the hub or Osmosis, and then basically it started gathering data on how clocks were synchronized for each of the validators that were running that. I don't exactly know how he did it, but I remember that the output was that they were like, out of all the validators, was like 1 or 2 that had a very, very bad, like off by, I don't know, 10 seconds or something like this. And the rest of them, apparently they were always using NTP, and so they were using like pretty much synchronized clocks. And at the time, everybody was, of course, using BFT time. So it was like kind of like a reality check, right?
Yes, we measured that on the existing chains. We didn't do this time, these measurements of precision. And there are some guys which, and also some validators that are run by, I don't know, by companies that are, so pay attention to have clocks synchronized. And these, of course, improves. Notes that having synchronized clocks will improve also the timestamp produced by BFT time, right? It's not required, but we will improve. And in the case of PBTS, it becomes really essential.
I think we can follow up. We can have additional discussions. Like I said, I think Adi put in the chat, we have other community calls that we can continue on this, but we can also, would be happy to be talking async through Slack too. So we'll follow up. I think this is a great feedback that we got. This is the first time, I mean, the work has been ongoing and we've been getting feedback, but this is like, now that we're presenting, this is a very valuable feedback, and I think these discussions are quite important. So we'll follow up. Okay, go ahead.
I was gonna
Laura.
say, yeah, maybe after we sync with the SDK, it might be worth like we can do an async upgrade, but if enough people would like another iteration of this, we can certainly host that as well.
Yeah. Unfortunately, this meeting, I think, had a little bit of a conflict with the SDK team, but they asked us to record, and they're probably going to be watching this session too. And then next time we can also probably have them on the call too.
Cool.
All right.
If no one has any other questions, then I guess we can end the call. And thanks everyone for making the time.
Thank you.
Thanks everyone. Okay, have a good day. Bye.